Whenever a chip works, it's a miracle.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. Today in the lobby, we're joined by a true pioneer in the world of wireless communications, David Su. He has a PhD in electrical engineering from Stanford University, worked on early wireless LAN chips before Wi-Fi was mainstream, and his designs have been used in billions of devices worldwide. He's spent time at both tech startups and enterprise engineering powerhouses like HP and Qualcomm, and he's now co-founder and CEO of Atmosic Technologies, where they focus on ultra-low power wireless chips and energy harvesting solutions. David, thanks for joining me today.
Thanks for the time.
I'm curious, has engineering and technology always been intriguing for you?
It seems like it's been there my entire life, into technology itself. And clearly going to college is probably where it becomes clear that engineering is the right major for me.
And you got into RF pretty early, I understand. Why did you go the RF route versus maybe some of the more popular tracks at the time?
When I joined HP Labs, I think in the mid-90s, right after my PhD, at that point, CMOS RF was actually quite popular in the research area. So I know very little about RF, so I thought, great, this is a good job for me. And I took the job. At that point, as you know, there's like no commercial RF products on the market in CMOS yet at the point in time. So CMOS opens the door for these additional layers of integration that you couldn't possibly do in the traditional RF technology.
And HP at the time had a lot of industry leadership in the spectrum analyzers and the RF area. What sort of projects did you work on for people who might be a little nostalgic for those products?
The group I was in, we were doing research in designing CMOS RF explicitly for home networking. Unfortunately, that never became a real product by itself, but we did a lot of good work back then.
What technology nodes were you working on at that point? I can't imagine it was nanometers like we're dealing with now.
To be honest, I don't recall exactly anymore. I would say it's either 0.35 or might be half micron.
Okay.
It's a long time ago.
Yeah, no worries. And then after Hewlett-Packard, you went to Atheros and Qualcomm. It was very small at the time versus HP, which was huge.
Correct.
Can you tell me about that transition and what prompted that for you?
A friend of mine joined Atheros as a founding engineering team member. So he called me up and said, come over for lunch. So I went over and I was blown away with the vision, the desire to change the world, the aggressive mission that I thought a research job was supposed to be pushing boundaries. This is really pushing boundaries and also offers that opportunity to actually see it all the way through to a product. So that was very attractive to me. In many ways, as an engineer, I get a lot of satisfaction seeing what we do into a product. So I like to tell people that I went for lunch and never left.
That's good. And you were working on like wireless LAN before Wi-Fi was mainstream. How did people respond to the concept of wireless internet?
Back then, clearly, looking back now, it's almost funny that Wi-Fi is everywhere. You go to every hotel, one of the first things I ask the camera is, what's the password for? Yeah. But back then, it's really the early stages. I think there is like 802.11, not even A or B, on the market, using multi-chip, using silicon germanium, who knows whatever technology they're doing. So the goal there is, can we now make it all into a single chip? Instruments, and that will change the cost structure, makes it much more producible. So yeah, so it's exciting times in my mind.
Absolutely. Is there anything you remember most fondly from that era?
Oh, there are many things. In many cases, life is a journey, not a destination.
Yes.
So I felt like I was very privileged to have this, what I call a front row seat, watching the evolution of a small company into a large public company and being acquired by a giant company. So this is pretty amazing, I think. I've been very fortunate in my lifetime to be able to experience that level of transformation, and also seeing a technology that goes from a novelty to everywhere. So to me that is very exciting from that point. Everybody that I work with thinks more fondly of actually the team. Every time we get together, everybody talks about the good times we had together while we work hard on creating something new. So ultimately, I will agree. The team is what we always most fondly look at on our experience back then.
I'd like to talk about the Qualcomm acquisition, which you alluded to in a moment. But as you've looked back at your time at Atheros, are there any lessons you learned, either painful or joyful lessons, that have impacted and influenced the way you started at Atmosic?
Obviously, we are habits of our past. So rightfully or wrongfully, what we learned back then changes how we behave. I guess the obvious thing in my mind is that scaling a small company is actually very challenging. There are ups and downs. You can panic every day, but it's like focus on what needs to be done, what you can do, make a difference. There are many things you can't control. It's okay. And then there are these things about what is the perfect solution? What's the perfect answer to any question that comes up? In many cases, what I've seen solutions or decisions made that seemingly seems suboptimal, but it turns out to be amazingly great later because we never have all the information. So it's how it evolves over time, how you adapt to the new information you came in. So I'll tell a short story here. We were debating over doing 11B because 11B was on the market now at that point in time. We debated, should we do 11B or not? And we took the debate to say, let's just do 11B. Who knows? It turns out that 11B was a bust. It's 11G that was what changed the world. But the decision to do 11B allowed us to have a 2.4 gig radio that allows us to do 11G. So it's how you make the decision we make. Ultimately, they led to success.
So even though the technology wasn't necessarily what you wanted it to be, it set you up.
Sets you up to be ready when opportunity strikes.
Yeah. The constellation charts on Wi-Fi just blow my mind these days.
Yes. I just, how many more dots can you fit into that?
It's like I can't even see the picture, let alone pick out IQ data out of there.
Yes, I agree. It's amazing what great engineers can do over time. I remember when we were struggling with 64 plan and 1024. No, not going to happen. But yeah. Sure. I'm sure the Wi-Fi you and I use today has it today. So yeah.
Yeah. And then in 2011, Qualcomm acquired Atheros, which, going from a small company to a company that literally has like their own skyscraper city in San Diego.
Multiple.
Yeah. That had to be something. Can you tell me about that time and what that was like for you and your teams?
I think Qualcomm is a very impressive company. And to me, I had previously a HP large company. And so it's not completely foreign to me personally. The one thing that I think acquisition, for people who go through acquisition, there are clearly differences. You have to change. You are now working for a different company with in our case, slightly different culture, because the company is much larger. And now what is good for a smaller company may not be good for a larger company. So some amount of adjustment needs to be made. So I think I think overall it's a good growth experience for everybody. I'm actually quite happy to say many of my former team members are still with Qualcomm today. So they clearly found a good home there. So it's good.
Yeah. Are there any things from Qualcomm, styles, culture, elements that you picked up from Qualcomm that you've brought over with you? Things that were maybe new, but you really found the value in?
I definitely see, as a larger company, you have a lot of advantages. You have scale. You can bundle when you sell to customers. And when you go to negotiate pricing, you have volume discount. So that's all great. And then running an engineering team in a large company is slightly different. So the value, I think, is structure can be of value. If you have more structure, then you tend to make less mistakes, less reliant on just individual talent. there's a flip side to it clearly. So there's that balancing act. So I think that transition at Atheros and then Qualcomm sort of taught me that balance between structure and what I would like to call craftsmanship. So there's that balance. You don't want to go too far one way or the other way.
How do you know if you've gone too far one way or the other way?
Either your chips become less innovative because so structure, nothing innovative ever gets done, or your chips don't work because you don't follow all the rules, you cut too many corners. So there's definitely a happy medium in the middle.
Yeah. Okay. That's good. That's good advice. How did your role change when you went to Qualcomm? What were you doing there?
The official title didn't change, but clearly is now I'm a much smaller piece of the bigger puzzle as a company. So the explicit role change actually is not very apparent. The main difference there is now you are interfacing with a much larger group of people. And clearly for the group and the company to function well, that additional level of coordination goes up quite a bit. So what led to me personally is the amount of time spent in technical details drops quite quickly. Just because there's a much higher level of engagement you need to be doing.
Are there any interesting firsts that come to mind where you and your team were the first one to do something new or different?
On the Wi-Fi side, there's a lot of firsts that we did in technology point of view. I would argue that we did the first fully integrated radio with analog and digital and get it to ship in the marketplace as a product. We were the first to actually put in the power amplifier on the chip as well and then ship it as a product. And moving into Qualcomm, I think that innovation rate continues. Now the team is larger. There's a lot more going on. The level of integration goes crazy. As we talk about 1024 Qualcomm, those are shockingly complicated things that they were first to market.
How did people react as you started to integrate more and more onto the chip? Were they surprised? Was it normal?
I felt like the trend line has always been there. As you know, over the years, the integration with digital is clearly there. And I don't know why we were among the first, at least the first that we know of to do this. I think a lot of it has to be not having a existence proof. Once you show it can be done, other people will do it too. So I definitely remember when we first proposed, the engineering team proposed doing this, there are other people who came by saying that, how dare you do this? Have you done all this other analysis around it? What if it doesn't work? But there's some amount of risk doing that. And that's where the structure versus innovation comes in. And some amount of boundary pushing is required for a company to continue to be successful. So
I find there's a lot of people who find reasons things won't work, but until you try it, you don't ever know for sure.
There's a lot of reason why things don't work, and sometimes things don't work. That is true. But the way I look at it is when you push boundary, an advice I got as a very young engineer from one of my mentor who has with some years of work before me. When things don't work, I was depressed. That he says you need to learn two things. If everything you do always works, you are playing it too safe.
Yes.
So that's a good advice I learned from him from the beginning of my career.
We say in mountain biking, if you aren't crashing, you aren't riding hard enough.
Okay.
You shouldn't crash too much, but yeah, same sort of approach. Yeah.
Yes, exactly.
I'd love to hear about the early days in the founding of Atmosic and how it came to be. Can you share that story with us?
After we got moved into Qualcomm, when I felt the team settled, I decided to take some time off. So I was out for a while. The funny thing is my son back then was a teenager. I remember distinctly, I don't think he would remember this, that don't you have a job to go to?
So it wasn't time quite yet to retire.
Yes, I wasn't going to retire. That was clear. So I definitely become interested in looking for what next. And some of the former co-workers also left Qualcomm as well. So we were getting together for lunch and saying, should we just do something together again? And that was the genesis. And we then reach out to, clearly when you want to start something, you want to reach out to experienced advisory people. So we talked to quite a few of our advisors back then on what should we do and what can we do. So it's more of the idea that we will do something first. And then now looking for what can we do. And the advice I got back then, which I think is still relevant today, is that find something you're passionate about. Find something that you can actually do well. And obviously, if it's a business, someone will buy. So somehow you need some combination of those three things we do. So we actually discuss what are the choices we can do and what are the things we are capable of doing. And the one thing that keep coming up actually has to do with totally wireless, which is what we know about. We're looking at just the amount of battery consumption you see in the world today. So back then, we were trying to get a good number, but the number we found back then is like 3 billion batteries were thrown away in the US every year. 3 billion by my calculation is 100 per second.
Wow.
And I'm contributing to some of that. And by the way, a more recent study from EU, apparently a more detailed study, is predicting that by 2025, we'll be throwing away 900 batteries per second.
Sheesh.
So it's a large number. So we thought, why would people do that? Why are all these small disposable batteries, quantum batteries everywhere? A good part of it is because of wireless connectivity. When you can be networked without being connected to a Ethernet cable, then it's harder to insist that please connect a power plug to it. So the mobility of the device really promotes this usage. So we joked at the early days that we are partially to blame. We work in an industry that promoted this battery usage. So if we just reduce the power by half, back then, say 3 billion in the US a year, there's 1.5 billion batteries a year if everybody does this. So it's a good thing to do and something that we know something about. So that's where we got started. And then as we're looking at the battery power consumption, we thought maybe we can add in energy harvesting and create solutions that will now have battery life that will last much longer beyond the low power or forever, or actually be completely battery free. So that becomes the genesis of the idea behind what we do.
To me, this looks like a very noble and worthwhile goal. Is there anything you've done at Atmosic that you're most proud of?
I think, well, what we have clearly the most thing, the proudest thing I have is actually we were fortunate enough to assemble a great team. So with our great engineers that, like a better word, left real jobs and come and work here. So that I'm very appreciative. I'm very proud that we actually have a great team here, and they have accomplished a great deal of work since then. So we have 2 generations of product on the marketplace now, and we started our first solution doing Bluetooth. And so this is a full function Bluetooth solution with the lowest power in the world. And the active power is 3 to 5 times lower than what you find from competition on the market today. So our goal is we want to be at least half, because back then we were saying 3 billion, we cut it by half, we got 1.5. So we achieved that goal. And the team was recognized by CES in 2020 with the Best of Innovation Award. So that was pretty cool.
That's very cool. How do you get power so low? That it seems like it would be non-trivial to just say, yeah, we get 3 to 5 times less power.
Yeah, it's non-trivial. And the way I look at it is that get to low power takes a lot of experience to know where the power is being spent. Where are the important places where you need to reduce power consumption? So having experience helps. And as you know, what's the saying? We always stand on the shoulder of giants. So most of these concepts are already there. It's like the ideas of how to reduce power has always been there. And now how do you adapt it for RF? So that took a bit of work to figure out how can we leverage good technique and idea from a system level, from the circuit level, from the design level. How do we make it to get to the lowest power? So it's some combination of that gets us to the lowest power.
And then I see you recently also announced some Zigbee product capabilities, also
Yes.
matter over
Yes.
thread and thread. Can you talk about what it was like to transition from being Bluetooth forward to other technologies?
So overall, from the very beginning, we've always thought of us as a wireless connectivity company, starting with Bluetooth. So the vision has always been is we are not a Bluetooth company per se. So the first step we took is we took our Bluetooth radio and make it configurable. So it would run Bluetooth as well as the 802.15.4, which includes Zigbee and Thread and Matter over Thread. So that is that transition. So that transition is actually smaller than you think in many cases, because the key is to now how do you enhance it and make it configurable to support both protocols.
While also dropping power, because I imagine a traditional approach to this would be we have, one chip or one set of IP that does this one specific technology, and by reducing overhead, you're reducing power. But sounds like you've almost gone the opposite direction.
Since we already have our technique on how to reduce power, so it's just a matter of now applying the same concept to a broader set of protocols and so forth. So it's some amount of so the incremental lift is a little bit lower, but still, yeah, as you know, supporting new protocol, the system, the software work behind it, yeah.
Yeah. Are you doing then like dedicated chips, or is it IP, or what does this sort of form factor look like?
So we are a IC provider, so we sell chips.
Okay.
So which means that we create a SoC that most of our block diagram would be quite similar. We have a radio system, we have a MCU, ARM-based currently, and then we have the memory subsystems around it, and we have all the I/O periphery and the standard I/O interfaces. So that's chip side. Then we have to create a reference design, power reference design that our customer can they power on, measure, and show that power actually is what we claim it to be. And then on top of it, we had to build this SDK software environments for people to develop their application on top and use the MCU to do interesting things. So it's an overall solution ultimately that we sell.
What's been the hardest part of thinking kind of full stack in the sense of what it takes for a person to implement one of your chips?
The way I look at it always is that ultimately what our end user cares about, which will influence why our customer can be happy, is what their user experience is. So optimizing on the circuit level is important, optimizing on the system level is important, and optimizing on the software level is just as important. So we actually are fortunate enough to have a strong team on the software side as well that can understand hardware and software interface and how do you leverage the power on the hardware side and make sure the software itself is optimized as well. So that we actually thought of from day one, in the sense that ultimately it's the customer, that user experience that matters. It's not, you can say, yeah, you turn it on the radio, see the power is very low. That doesn't really help anybody.
Yeah. Yeah, the number of development boards I have over here on my shelf that are just too hard to turn on, it's like, I'll just, plug an Arduino or something, because it may not be the best, but it might be the easiest. Yeah.
Yes, agree.
Who are some of your core industries, and where are a lot of these, being implemented?
So our current products sells into several categories. The bigger categories include mobile accessories such as asset tracking, consumer asset tracking. So we got a good footprint there. We do a bunch of home accessories, IoT products as well, including remote control, which is turned smart with Bluetooth in it today. And we also have some products in the PC periphery, keyboard and mouse type design. So those are the three areas that we have the most traction today. And we are definitely branching out into industrial and commercial side. We have a initial win now in electronic shelf label. So those are the categories that we're in.
Shelf labeling. I keep hearing like inventory management and retail shelving being a thing that surprises people. Is that something you saw coming, or are there any unique challenges to that?
The way I look at it is, as you move to industrial and commercial, some of them are still proprietary. They're not completely standards-based yet. So then you have to ask yourself, do I want to be a proprietary protocol custom chip business versus a standards-based solution? And there's definitely a lot of movement now in the area to make it standardized.
It seems like standardization in general is the route that we end up going as a technical community. But
so far, yes, that ultimately is a right path in my mind as well.
Yeah, I do see the allure of the locked ecosystem, though, from a business perspective.
Yes, if you can have a good system that people continue to buy and you are the only provider, hey, it's great.
What sort of industries do you think will benefit the most from ultra low power RF capabilities?
The way I look at it is actually much more broad than that, in the sense that nobody ever complains that your power is too low.
Yeah, it's never too low.
So I think all of us can in many ways. There's not a single category of product I can think of. Then your question probably is, where are they most sticky? Where does it matter the most? So to me, I like to address places whereby two things. One is high volume, and then there are applications whereby the cost of ownership is very high to change. So those are the two categories probably is the most beneficial. And for asset tracking, if you can't last long enough for your duration of tracking, then it becomes very inconvenient, to say the least, in the sense that it's like you put a tracker on your suitcase and you forgot about it. And then the day you needed to find out where is my suitcase when you land at the airport, well, it doesn't quite work today. That is embarrassing. So.
Yeah, like when's the last time I charged that thing?
Yeah.
So clearly, battery life and using very low, ultra low amounts of power is something that's just generally useful. How does the software and the firmware play into battery life versus actual chip architecture?
I think it's just as important, if not more so. So you just imagine a radio design on the front lowest level. You have your physical radio. It's an SoC. There is a processor on it that's running. How much energy does the processor take to run also matters. More importantly is that if in your software you keep your radio on longer than you need to, then imagine I said my radio is 3 times lower power than someone else's radio, but I kept it on 3 times more frequently. Then I just lost all of the advantage I had. So now as a system become more configurable, software plays an even larger part into the overall solution.
Yeah, one of the things I see on the test and measurement side is you turn your radio on, you have this big spike, maybe a couple millivolts, a couple dozen millivolts, and then you go into the sleep mode and you have this little timer, and it's so hard, visually such a distinct difference between the two.
Correct. Yes.
What are some techniques or technologies that might surprise people who are unfamiliar with low power firmware standards?
So from a low power point of view, sleep power is actually very important. So there's a lot of work going into how do you keep your power doing minimum work and still be able to wake up. So that amount of engineering is quite interesting in my mind. Yeah. So how much work goes into keeping your idle power, standby power low, plays almost just as much as the overall system in a lot of the IoT application. Because imagine I have a device that turns on once every second for 40 milliseconds, let's say. In that case, the active power is probably important, but not as much. If your leakage is high or your standby power is high, you just lost everything you just did again. So system design is ultimately key.
Absolutely. As someone who's been in the chip industry for a little bit, what's been interesting or most surprising as we've gone from 350 nanometers down to like 3 nanometers?
Well, I will date it a little bit more. My first chip was 2 microns. So.
Okay. So 2000 nanometers, yeah.
But I think each geometry has its own challenges. Looking back, you would say the earlier geometry is the chips are so much less complex.
Yeah.
So they are clearly easier to do, but the tools are so much harder. The computers are so much less capable. So the human requirement is much higher. The chance of chip working, whenever a chip works, it's a miracle. There's so many things that could have gone wrong for the chip to not work. But amazingly, miracle happens all of the time throughout the world. So testament to great engineering, great tools, great educational system. But going back to the geometry side of things is that if you look at ancient geometry, the transistors go very slowly. So as you try to push yourself towards RF, you really have a challenge to get there. And in the early days when we were doing our first radio for Wi-Fi, the use of inductor is high. You need a lot of inductors to tune out those capacitors. So it's a different design challenge in that case. Today, as the technology goes faster, then you still use inductors to boost yourself up. In many cases, to save power. Yes, you do need some for your VCO and so forth. But the need for inductors changes. But the complexity of the system itself now, if you look at the overall block diagram itself, the percentage of the RF is now like a smaller percentage of the overall chip. So the complexity becomes amazingly high. So we have traded the simplicity, the complexity of designing a difficult circuit to system complexity.
Yeah, that makes sense. I love the philosophy of every chip is a miracle. Just the fact that we can more or less take like a vat of sand and extract this perfect crystal and slice it down and shine light on it and acids. The concept is absolutely bonkers that our entire technology stack runs on.
And no one sneezes on it the whole time.
Yeah. Yeah, it's like, oh, that was a 500 megahertz processor. Remember how, old school that was? It's like, whoa.
Yes.
That's amazing that we have a single transistor on silicon.
The technology really I felt like we are very fortunate to live in a time whereby you see such amazing progress as Moore's law. Looks so easy that we just take it for granted.
Yeah. It's and people are doing it in their garage now. Like it's crazy. You also have done some work around energy harvesting. Sounds simple in concept, as we're surrounded by sunlight and RF signals. Why not just grab some of that energy? Sounds great, but that sounds also really complicated when you get into the nitty-gritty of it. Can you talk a little bit about what your involvement in research and what your activities look like around energy harvesting?
Energy harvesting, as you know, has been around forever. And we have solar panel on the rooftop. You have windmills, and all these are good things to have. And what I am looking at here essentially is, as we spread all these, sensing nodes everywhere, and you don't want to run a wire to power all of this, and you don't want to run batteries everywhere on all of those devices, what can you do? So having some form of localized energy harvesting, I think would be key for it. And the most popular one that we ran so far is photovoltaic. Well, I think in large part is that all of us understand why it is immediately. We've seen it on calculators.
Yeah.
So if you haven't been paying attention, the quiet revolution of those calculators, this is a few years ago when I was shopping for a calculator for my kids. And it's interesting that you go to the store, every calculator comes with a small PV panel, which is amazing, which is a great thing for the world. And now the question now is, how widespread can it be? Those calculators do not have connectivity. Connectivity, we have proven that you can now lower the power of the connectivity to be no more than what you find in a calculator. So why couldn't that spread? And indeed, some of our customers are beginning to do that. So you have seen remote control now with little solar cells on them. So I thought there's a fascinating area for potential usage across. By the way, smart remotes is about 300 million units a year. So it's a large market. A lot of batteries are being used by that, including my household. And then there are other choices of energy harvesting. You can look at mechanical, thermal, or even RF. So there are definitely a lot of opportunities for us to really make a big difference in the world by making harvesting mainstream.
Yeah, I suppose as the power requirements for devices comes down, then the viability becomes more
much easier.
Increases. Yeah.
Yes, absolutely. Because I was just mentioning that to someone else the other day, is that the first Bluetooth radio we designed probably now 20-some years ago, I think draws about 100 million, some ridiculously large current.
Yeah, that's crazy. Yeah, by today's standards.
So we are now like orders of magnitude lower power than what it was back then. And a lot of our typical application, the average current is in the order of tens of microamps today.
Sure.
So now it's a huge several orders of magnitude difference. Now harvesting that energy is now so much easier now. And imagine moving forward, that drops by another order of 10. You can, I think, harvesting will become easier and easier going forward. So you can imagine the solar panel, the little photo cell becomes 110.
Yeah.
Then become a much of a no-brainer.
What is different about creating energy harvesting circuits? Is there anything surprising or unique or unusual?
I will admit that I underestimated the effort.
Yeah.
I thought, sure, we can do a good energy management or power management circuit. So it's just design.
Yeah.
Right. So one thing is that I'm sure you can relate to this concept of maximum power transfer. Depending on which source it is, you need to create the right match to get the best energy out of it. And so that you need not to be adaptive. So that takes some amount of work to do. And then the other concept is at the beginning of time, what you design better be right first time, because you do not have the option to say, on power up, I'm going to configure myself so that I can do the right thing. So that becomes a second level challenge because clearly you are the power, so you can't rely on adaptability to do it after power on.
Yeah.
And then the third thing is that if you truly become battery free in an energy harvesting solution, which we probably spend the most time on, is that now you're going to get potential brownout hundreds of times a day, potentially. Now in the corner cases, at least when we go through school, people say VDD power is AC ground. You can count on those things. Power and ground are constant. You can always rely on.
Sure. Yeah.
But now you can't. Which changes the equation quite a bit. So it's more complicated than to be fair, I gave credit to at the beginning, and we learned. Yes.
You almost have to sense when you have power and when you don't and respond accordingly.
And then you don't have power yet.
Yeah. Without power. Yeah. Oh goodness.
Yeah.
I'm curious to pick your brain. What's next when we look out 10 years or 20 years or even 50 years? What's next for state-of-the-art low power wireless devices?
Well, I don't know the future, so but
Sure.
Ultimately, we all want to have devices that are always on, always connected, and takes no power. That's the ultimate goal. 10 years, you say 10 years, we can probably move quite a bit more than where we are today. There'll be a lot more devices that are always on, and the amount of power needs for the always-on solution has really come down. Just simply as simple as your keyword recognition, Hey Siri type power consumption has really dropped over the last 10 years, for example. You would expect that to drop by another order of magnitude 10 years from now, would be my guess. And they will enable all these additional devices, and then harvesting become easier, and we might have a lot more devices glued to our body beyond the phone, the earbud, the key fobs in your pocket. So that will continue. I think the number of devices that you get around you will continue to grow. And my hope is that at that point in time, the cost of ownership of this powering these devices will be much less of a problem.
Let's hope so. Yeah, well, thanks to people like you working to make this a reality.
I think it's the industry. So the goal is to get more and more people to be on the same side, and consumer has a role to play here too. If consumers value cost of ownership, then there will be the reason why all of us in the same industry will push in the same direction.
So as we get near the end of our episode, we like to do a lightning round. It's some quick questions, quick answers. If you could wave a magic wand and remove a requirement of physics. What physics? The law of physics. I like to ask this to RF people. What would you change about the way the world works from a physics perspective?
I think there are many things we battle on, but I feel like every one of them has a path to a acceptable solution. So I think power is one thing. I would love to have a case whereby we don't need to obey the rules of power. Power in does not need to be greater than power out. Then it would be great, but that is not going to happen anytime soon.
If I find that magic wand, I'll let you know.
Okay.
You started at Hewlett-Packard, famous for the HP way. You've talked a lot about teams and finding so much value and fulfillment from the teams that you've worked with. Do you have any advice for folks who are building and developing teams, philosophies or things to think about that will help them build similar teams?
I really appreciate the management style of HP. Right, at least working there, I felt very respected, very supported. And so ultimately, I think in every case is that, right? So how do you make sure that you leverage the talent of everybody on the team and make sure people feel respected? And I know when I was back at HP, I remember two lines they get quoted a lot. One was management by objective, which I think is fair. You trust people to do the right thing with respect. And then there's this management by wandering around. I don't know if you remember that phrase.
I love it. We still do it. Yeah.
Yeah. Yes. That in many cases helps the quote unquote management to understand what other people are and listen. Because the best ideas generally came from probably not the manager themselves. It's the team. So I like both of those. Wow.
That's wonderful. If someone were to want to get into semiconductors or RF technology and wireless communications, are there any things that beyond the normal, Maxwell's equations, any topics or capabilities that you would recommend they pick up?
The general entry point for almost all of us is education. Right? So education both when you are in school. In many cases, the education allows you to be hired into the company. To be fair, I'm old enough that I got hired without actually a proper CMOS RF education. but this day, if you try to get into the job without the education, may be harder. But that I think is the first part. And the second part clearly is wherever you are working, continue learning. That always be helpful in terms of getting into the area that you are not familiar with.
Well, that's it for today. But David, thanks for being here. I enjoyed talking with you.
Thanks, Danielle, and great talking to you as well.
That was David Su, co-founder and CEO of Atmosic Technologies. As always, thank you all for joining me today in the lobby. If you enjoyed this episode, please share it with a friend or a coworker. And we love hearing from you on the Moore's Lobby and All About Circuit's social media pages. So come check us out over there. And if you haven't already, please subscribe to Moore's Lobby in your favorite podcast delivery tool. I'm your host, Daniel Bogdanoff, and I'm honored to get to share this time and these conversations with you. So thanks for tuning in. I'll catch you next time.